Okay. Well, yeah, I mean, I think that's pretty much it. I guess it's good time for open discussion. If anybody wants to jump in, if anybody has anything to share, if anyone has updates or anything along those lines.
Yeah, I want to say something. That video, I saw that video about a year back. It's by a Singaporean, and he spent a lot of hours trying to figure out what the circuit actually does. But his conclusion was that it was basically a lifter. And that didn't make sense with me.
That doesn't make any sense. There's no way something that heavy can be a lifter.
Yeah. So he was coming from it from a predetermined outcome.
Yeah, I mean, I think the only two options for Alexei Turkov devices, either it's some magic that he doesn't understand and we don't understand, or he's just holding it up by a string.
Oh, go ahead.
I'm sorry. I don't want to be negative, but I've reached out to him. Benjamin, you may have as well, but I've reached out to him. I reached out to him once myself, and then I talked with Mark when he did. And in both cases, Alexei redirected back to Western. He redirected me back to other folks. And then I think he told Mark about Tom Bearden and stuff like that. And so my takeaway there was he wants to do magic on YouTube, but he probably doesn't want serious attention, I guess. Now, that was my opinion. It's just an opinion. But
yeah, when the group I was talking to, I was leaning towards believing him, and so I sat down and started deconstructing what he was doing. But then we had one of our members was a Russian guy who used to live in Russia, and he and a few other people did not believe that he was right. But I said, let's give him the benefit of the doubt and try and bring him in and let's talk to him. But he was very reluctant to do that. So we had to drop it at that.
And he also offered to sell you a model, right? How'd that go?
No, he didn't.
Oh, no, that was me. He offered to. Well, I offered to buy one from him. So it's not that he was trying. I don't want to make him seem profiteering. I offered to buy one from him last year, and I said, "How much would you sell me a working?" And I also what I said was, I don't want to steal your idea. I said I would put this up online. I said you would benefit from this both ways, and I'd be happy to pay you for it. And he said that he would sell me one for, I think it was 2,000 euros, but he guaranteed me in the email that without his expertise, it would never work. And that was where I dropped it, So.
Yeah. Apparently there's a lot of fiddling that goes on with the dials, and there's no working theory that explains why it would work. So where to even start? He has two Tesla coils that are that are working in harmony with each other, and then there's a high voltage field, then there's spinning disks, and then there's ultrasonic transducer on the top of it, and then it all has to be tuned to what? There's way too many devices there to tune. Like even the spinning disks, you have so many options. How many RPM? Is it spinning up? Is it slowing down? Like what is going on? There's so many things. And
actually, if you were at my presentation, I explained, because they are both, his and Podklenov's device are both related, and both of them, I understand, trace it back to Nazi Bell experiments. But there is a working theory, and you shouldn't need high voltage. You need about 800 to 1,200 RPMs. It's all there in the presentation, on March 20th presentation. And there's a formula on how to calculate what effect you get.
Yeah, but still the biggest problem I see in all of these is you don't even know what materials that they construct things out of. And there's a lot of conjecture on the Bell, and depending upon who you read, depends on which materials you get to get to use. So, yeah, until you actually know the materials, I think it's going to be very difficult to figure out a lot of the issues that people want to know. The other problem on like there's people who say, well, I have pieces of something and it's an alien artifact, but in every case that I've looked at, there's nothing alien about anything that anybody's ever showed. So if anybody has any pieces that they say are truly alien or whatever, well, my lab has more than enough technology to check out any material that you can think that you think might exist.
How would you know if it's alien or not?
Well, that's a good question, isn't it? So, but when you look at the in material science, which is what I do now, we have lots of databases of materials that we can scan for. So anything that you would think would be alien probably wouldn't be in that database, would it?
No,
So-
probably would. Why wouldn't it be in the database?
Well, you know, if I remember right, and this was intriguing, Mark, you might have said this. Somebody told me this. They were talking about measuring the isotope ratios. That was supposedly
right,
how you
right.
could tell if it was alien.
And the
Well, that would
isotope-
tell you if it came from a different
that-
supernova.
I have a question. You were talking about a system that had a whole bunch of different settings that you had to figure out, right? And like what speed, you know.
That was the electric Turk of gravity flyer device. Yeah.
Yeah, that. Why couldn't you use our software to figure it out? In one of those combinations.
Well, if I could jump in,
Would
John,
be-
John, if you guys had something like that, Mark could probably use that for a variety of experiments. And I understand, I forgot the name of it, but basically you let it run parameters and it comes up with the optimal parameter set for any one of.
John, if you guys can write software that
Yeah, you ran the.
if you can write software that can control a rheostat and in order to change our power output for the electromagnet, and at the same time monitor the magnetic field strength so that it knows that it's going up by X amount of Gauss, and then at the same time measure the weight on a sample and graph it all out, that will be very useful for the Alzaphon experiment. You think you can do that?
Oh, yeah.
You probably,
But I mean, you're
probably need like
that
programming.
would be basically sensors. Yeah.
Yeah, it would be a software hardware combination.
Yeah, and that was,
All right, what we're.
Jump in. Is it okay if I jump in?
yeah, go
Go ahead,
for it.
Amar.
I interact. I
talk.
I talked to Alzaphon and just kind of wanted to side note that his father's book has a section in it that has to do with these distributions, and I think in our paper too we talk about that. Remember, John, the paper from Russia, the Russian physicist, the Russian scientist.
Oh, yeah, that's right.
And anyway, I mentioned to Alzaphon, I said that your dad, in his book, and there's a particular page, he's talking about something like that. And I wanted to mention that, just so you know, because that kind of reflects our second paper. That is
Is this the
cycles.
book-
Sorry.
Is this the book you're talking about?
Yeah, is that the Alzaphon book? Yeah.
Well, this this is the paper that was written by the dad.
Yeah, and then there's I think, I don't know, it's page 126. It's one there somewhere he's talking about the distribution. I don't know. Maybe we can't look for it now, but probably in there.
Oh, you're probably talking about the book that was written by his son.
Oh yeah, that's it. That's the book. Yeah.
Yeah, this was not written by Frederick. This was written by David.
Oh,
And he said
David
on
wrote
page
it.
121.
And David actually has
Yeah, I
come
read
to
that
several.
too.
David has
Huh?
come to several of our conferences as well.
I'm connected with a few of these guys. Yeah, I know it's in the book. Well, I brought it up just because
What page?
I think it's I think it's 126. I don't remember now, but it has to do with a distribution and some kind of a distribution, and it has to do with something similar to what we were talking about. It's going to be a long shot right now. I can't. Sorry to do this to you.
A distribution of what?
It's like a I don't know if it's a normal distribution, but it has something to do with things that are not that like they're cycling. We show that in our paper too. So you have humps.
Oh, right, that.
Yeah.
Yeah, we
I
figured
think it's in
out
his.
what it was. Yeah, what was happening is that there was regulation going on, and it was eliminating behaviors that. And what happens when you do that is that you get it takes things out of your database, and you don't get a smooth curve anymore. You get something with bumps in it. We did an experiment in our paper too, and that basically is what happened. We had the system set up. It was regulating the control of traffic network, and when you looked at the statistics, they were all bumpy, because a lot of the behaviors that are ineffective were removed from happening.
I can't say I understood any of that, but
Our paper too, we talked about that.
I'd have to go. Because I sent Alzafon, I sent David a message. Hang on, I'm gonna close this. I sent David a message about that, and I said you're about the page, and now I have to go back and look at the message, and in there I recall.
are you talking about these type of plots?
Yeah, what does it say on the top? Does it say anything?
They look Gaussian, but they've got bumps in them.
It has to be Gaussian with bumps. Yeah,
I don't know what you're talking about.
Yeah.
I'd have to find that page. But anyway, the point is that he was saying something about if we understood more about this, something along those lines. And I don't remember specifically. But
Amar, would you be able to make the software for that device that I talked about? You probably need like a Raspberry Pi or a Arduino style device that can connect with both the power supply to control the amount of power going into the electromagnet, and also measure the Gauss coming out of the electromagnet, and then step that slowly up and measure for weight loss in a sample. Can you build something like that?
no, I'm not in the position to do so. I can't.
So what's
do it.
your software actually good for then?
My software is specifically good for, as I mentioned earlier, it has to do with understanding the quantum processes. So you're trying to separate the signal from the noise, and that's very important. If you don't know if you can't do that, then you run into trouble, and you can't. It's a quantum thing.
But we could run the experiment. We can play with the power, which adjusts the Gauss and the coils. That's one of the things we can do to change the disturbance. Matter of fact, we could be searching for, what is the optimal amount of what's the optimal B field to get whatever it is we're trying to get. Yeah, that's all part of what we're doing.
Okay.
Yeah, I would imagine that. I mean, you might have to tweak the software a little bit, but I would imagine that something like that, especially with like recursive neural networks, basically you just tell it what you want to find, and it just runs simulations until it finds it. It might not get you all the way there, but it might save a lot of time and effort. That was one of the reasons that I thought it would be great to have Amar and John on, was because they're doing modeling for stuff that's outside of standard science.
Now, the problem with the model, though, is that whatever you put in, that's what you get out. So if you put dunk in, you get dunk out.
Oh, that's what I do. I'm looking for things that You don't know what is there. And the underlying model does not exist. But I'm going to be very frank. Well, I'll be straight out with everyone here. I'm not a software developer. I'm a mathematics is my discipline. You know, that'd be kind of strange, but software itself is a very specialized discipline. So the things I developed was a mathematical algorithm that was developed by a coder, but I'm gonna have to upgrade it to what to what John is doing, which is right now in progress, work in progress. That's what happens when you're on a shoestring budget. You're not getting funding or anything of sorts, and you have to work with what you got.
So, yeah,
On
just based on the
the- on
statement
the-
that
on
you
the-
just made. Sorry.
Huh?
Just considering the statement that you just made.
Yeah.
When we did background scattering on radar signals off of waves, so you know, we use nonlinear mathematics to solve for those scattering issues. Aren't you using a form of nonlinear mathematics?
Yes, it's seamless to nonlinear things. Kind of being a bit, well, I can get into details, but I'm trying to keep it simple right now. It's not,
Right.
it's a bit, yeah, I mean, I can reference a paper if you like, but it's not going to do any good. I mean, it is look, let me put it like this. It lives in nonlinear. It doesn't have anything to do with linear at all. So
Right.
that helps
Okay.
answer your question.
That's fine. Thank you.
Yeah.
Anyone else have any questions?
I was
Oh, Ron
we
Keto,
know
one more
when
time.
our stuff works.
Go ahead, Ron.
Am I here? Am I live?
Yes, you're alive.
Okay, the name of the person who has the Alexei Chekarov device who died, was his name Chris Hardiman?
Yes.
Well, Chris Hardiman worked with microwaves. He has a tripod microwave device. Have you ever seen that?
No, but I got a lot more excited now.
Yeah, he has it's in his garage. It was 6 foot tall. The bottom is an equilateral triangle at the corner of this 3 foot. I'm going to use approximate dimensions. The bottom is probably 4 foot by 4 foot by 4 foot equilateral triangle. On each corner is a large ball. On the top is another triangle. I think it's equilateral, and it's also what it is. It's at the top they have a magnetron. There's a magnetron at the top. If you type in Chris Hardiman and you type in microwaves propulsion, I'll tell you what, I'll find it. But it's Chris Hardiman. He's been around for years and he is good. Chris Hardiman is great stuff. I may have been in contact with him. He could be my age. I don't know how old he is, but his microwave experiment supposedly. Oh, I think it may also have been linked to Jean-Louis Naudin laboratories. But I'll send you the thing for the Chris Hardiman propulsion device.
We're in contact with his widow about getting all the equipment, actually.
Yeah, because I've seen some of his stuff. I looked at some of his stuff, and I go, oh my God, we probably were in contact 30 years ago, back in the 90s.
He's been doing this for a while. I mean, if that's the case, we'll probably expect a lot of equipment. I might actually, have somebody fly out there to go look over everything and help pack it up.
Yeah, because what he does, I'm impressed by him. What I want to do, I'll dig it up and I'll send everybody on the list. Also, I send something out. Yeah, I send out the Silpho Moore saucer thing, but I'll send out a new one, and I'll send out the one on Chris Hardiman and the tripod magnetron. It's I don't know what effect it is, but it's microwaves. He saw something. It was big, and it was unshielded. I think it just sits there out in the open.
Oh, well, maybe that's why he had his heart attack.
Oh, yeah, I'm saying. Okay, well, I'll beam you some stuff. So I think I'm going to go into my email now. So nice meeting everybody and great presentations. Take care.
Happy Easter.
Thanks, Tim. Thanks, Mark.
Bye, Ron. Yeah, what a small community. Everyone knows him. It's a real shame when people like this, pass on because of simple mistakes that they've made without protecting themselves. We have here at the lab a room size. It's like a 6-foot square Faraday cage of where we do most of the experiments. Hopefully his device would fit in there, so we'll be able to protect ourselves from it. But from flying saucer accounts, people who've gotten close to them have gotten burns and radiation sickness and all that kind of stuff. So just like you're building a jet engine, you don't want to stick your hand inside the blades while it's turning. There's inherent danger to any form of propulsion. You just got to understand it and protect yourself from it adequately. And that's what we plan on doing.
I was going to ask John. John, could John's software right now, the way it stands, could it be of any use? John, what do you think? Could the OpEMCSS by itself?
Well,
I mean, for the things they need, they may not need what I got.
Yeah, we got to have what you got because we're doing quantum fields, and they're very, we have to somehow untangle that. Where the problem I had with the missile, we didn't have a problem. I mean, we were able to measure things and map directly into the feature space. There wasn't any problem with that at all. I didn't have anything like what you got to solve that problem. I would imagine most problems are like the missile problem, where the measurements are clean and there's very little noise involved, and we can take care of the noise with clustering. So yeah.
Will, did you have something to say?
Me? Oh, well, based on your comment about the UFOs, I thought the coolest comment was the Nazi Bell scientist that got to melt like plants in front of their toy. So I just thought I'd throw that out there.
They melted plants?
They melted like plants, according to the book Nazi Bell. Yeah, I thought that was pretty cool. So, and after a while, they put on some type of rubber suit to somehow protect them. So it's in the book Nazi Bell, originally written in German, but translated in English. So, yeah, but as you said, it's a good tale on safety first. In my lab, everything is safety first. So, as you said, there's never a single person left in the laboratory for any reason. So, have to always have two people. So
well, when you're running experiments, for sure, yeah.
I worked in a radiation lab, so I would know, because as I mentioned earlier in the presentation, I worked with in the LENR, low energy nuclear reactions at Cal Poly. So you got to know where the heck you're walking in the lab. Sometimes you might be shooting beta rays. Don't walk through that place. So
Look at my
happened.
My key
actually almost happened, and the guy literally screamed, and he was teaching a class and says, "No." Yeah, you wouldn't notice that, but it's that type of thing. You wouldn't notice it, and you got to be careful. Yeah. So.
Yeah, I use XRD and NMR and all these type of devices. Also a lot of high voltage stuff. So Totally agree. And always have a badge. If you're going to work with
Right.
anything that can potentially generate X-rays, you have to have a badge.
Mhm.
And there's various procedures for using those badges. And it's very important to generate monthly reports on each person who has a badge. Because if you go over the limit, you could potentially hurt them.
Yeah. We had a badge.
Yeah, I have a little keychain over here that it from Nuke Alert would actually it can detect X-rays and gamma rays, and it like makes a chirping sound whenever it goes up the radiation levels. So and we also have lots of detectors in this lab. There's an oxygen sensor because we do have liquid nitrogen in here, and the liquid nitrogen replaces the oxygen in the air. We have that's basically a vacuum pump that pulls air out of the lab, so we can move that around to any part of the lab that will be making noxious smoke. We have a range of detectors for all different frequencies and lots of radiation stuff. Yeah, there's a lot of detection equipment here in the lab, and alarms can go off and stuff like that.
Yeah, do you have ozone detectors? I mean, you did say you work with high voltages. High voltages generate both X-rays and anything over 15,000 volts. Actually, maybe
You can make ozone with lower than that. We have a great ozone detector.
Dangerous. So.
Okay, we have a great ozone detector. It's called our nasal passages. Ozone is very easily detected by its smell, and very familiar with that smell. But yeah, ozone is it's an irritant, and at high levels it can really cause some damage, but you can smell it at that point because it has a very strong smell. The danger is the things that you can't smell.
Yeah. So anyway, just be careful about your high voltage use. So.
Oh yeah. Yeah, we have a 1 megavolt Marx generator here too, and that we have a pull string for. It can make a 4-foot spark, and it's 7 feet tall. So we only run that when it's in like the center of the room, and not in this room. We have another room back there where we can run that for different experiments. It's basically simulating lightning.
Did you build that?
It was mostly Jeremiah's work. I helped him a bit with the soldering, but yeah, we put it together off of these panels that we got from, like, I think it was X-ray equipment. So it's like a whole bunch of 30,000 volt capacitors, and there's 2 capacitors per stage for a total of 960,000 volts. So we call it the megavolt Marx generator.
Sounds pretty cool. It's good that you made it yourself. That's a good learning experience.
Oh yeah, I mean, we built a lot of the stuff ourselves because they don't exactly have laser interferometer tables at Home Depot.
So that's true. That's true.
Yeah, but they do have PVC plastic, which is a very, very good dielectric material, and that's what we use as the scaffold for the Marx generator. And for a lot of the other equipment, we made it out of the PVC plastic stuff, which is awesome to work with.
Yeah, and as you mentioned that, where did you get your ABA filament? Because I've been looking online and I can't find it anywhere.
I got it from Amazon. Let me make sure that it was ABA. It's not like a standard plastic that you normally use.
There is ABA, but it's only used in blow-in plastics, as far as I can see. I couldn't find any filaments at all.
Just give me a second. I'll find it for you. Should be some here somewhere. Oh, ASA. I'm sorry, I got that wrong. ASA.
ASA. Okay.
ASA as in snake. Apple, snake, apple.
Acrylic is a styrene. I see.
Yeah, this has from my research, it has the highest dielectric strength of any 3D printable material.
Really? That's very interesting.
It also has a very high melting temperature. So you need to get your power supply and your all that stuff need to be ready for extreme heat. I think it's like 250 degrees centigrade.
I think
Yeah, 240 to 270 degrees centigrade is the range that it needs. Very high
That's not-
temperature.
oh, I'm over 300 on these two, so that's fine. So
good.
cool. So always good to find a new plastic because you never know what they can do. And I do a lot of cryogenics, so always looking for something that can deep freeze. So
I don't know if ASA can deep freeze, but that's a good thing to mention. Do you know any plastic that can hold liquid nitrogen without cracking?
I use ABS for that
ABS can hold liquid nitrogen, right?
very nicely.
It's good to know because we've had problems with our last experiment holding the liquid nitrogen for the Dewar, and because we used PVC for it and just started leaking.
Oh, that would shatter. So that would shatter. Yeah, I would say I didn't use liquid nitrogen for a door. However, I mean ABS for a door, but I do use ABS for the fittings in my superconducting experiments because we design superconducting materials. So yes.
Okay, very cool. Anyone else? It's been a pretty slow day here at APEC. I think Easter and all that has has everyone gone to hanging out with family and whatnot.
Yeah, I think it's kind of slowed things down a bit, you know. I was really excited though. I mean, and so I absolutely promise, swear to God, I will fix the Roger video. And I will also install that plugin too. As soon as we stop recording, I'll go back in and install that plugin. That way, next time we have a video like that, I can play it, or if you want, you can play it. So
yeah, we should do that.
Well, should we wrap things up, you think, Mark?
I'm ready to go. I mean, I don't really have anything else to talk about. Just waiting for my 3D printer to arrive, and then we can move on with Alciphon. And I think Jeremiah has a couple experiments, but he couldn't make it. And we'll talk about them next time.
Yeah. Well, no, thank
By the
you.
way, which 3D printer did you order?
It's from Project R3D. It's like a small boutique company that basically of 3D printer enthusiasts who decided to make their own printer that wasn't mass produced yet, and it has a really cool printing bed that uses spring steel that you can just snap, you bend it and it comes right off, and it has a whole bunch of really cool features like super strong aluminum
So
studs.
is it that dataless?
Yeah, the dataless, and we also got their upgraded shroud and stuff that aren't even on the website yet. So, that's the printer we got. Supposed to be accurate down to 10 microns.
It looks very nice.
Yeah, we'll give you a review on it in 2 weeks.
Yeah, I'll be interested to see what you think about it.
I've seen some reviews online so far, and they looked pretty promising. And this will be my 4th printer, and every single one since the beginning of when I started, I printed on it until it died. So this is my 4th printer, and hopefully it'll live long and prosper.
Yeah, and the price is not bad either, too. So that's the price looks pretty decent. So yeah,
there are some cheap, junky Chinese printers out there, but they don't have the level of accuracy and the nozzle temperatures that I need.
right. Yeah. So yeah, we make our own 3D print resins and everything here in my lab. So because we 3D print superconducting materials, superconducting devices. So as well as, yeah, we develop, we have new forms of ceramics that we are developing and making for 3D printing, ceramic printers. So
What kind of material, what kind of superconducting material can you 3D print? Nitrogen temps or helium temps?
We have, so my colleague and I, we've invented a new form of superconducting material. So it's, I should say, we actually, we were the first people to make YBCO nanotubes, as well as nano crackers and nano super crackers, I guess, as well as we're the only group to also discovered how to make YBCO spirals, which we're using, which are nano size, and we're using for new forms of antennas and stuff like that, as well as radiation devices. So
one of the experiments that we're working on is the Podklanov impulse experiment, which uses a bilayer of YCBO with a semiconductor in the middle, where they called it the Josephson junction. Are you familiar with that experiment?
I'm familiar only with what I read in the media. I don't know anything beyond that. So I think one person in the last conference had said something about it, but beyond what I've heard you guys talk about and the media, I don't know anything about it. Not really. So I never really followed that very close.
No. Can you print YCBO in large disks?
We have a new 3D printer coming in next month. So we can probably, I think we can print 24-inch disc. So with our new 3D printer.
Is this pure YCBO or is there resin mixed in with it?
No, it would be a pure YBCO ceramic. So.
Wow. Okay. Yeah. We're definitely gonna have to talk then, because we'd like to get some. I mean, 24 inches is insane. NASA had trouble getting 8 inches.
Mm-hmm.
Yeah, if we can get something like that here in the lab, there's a lot of experiments that I want to try.
Yeah, there would have to be a lot of discussion on that with the business part of my company in Singapore. I have a company in Singapore which would regulate how we would proceed on something like that. So that would have to go through the business group. Yeah, so yeah, I have a company, but also a business group which actually handles all of my inventions and technology that we develop in my laboratories.
Why out of Singapore?
Singapore. I would have to get the name card.
No. Why do you select your business group out of Singapore?
Why
Because I'm
Singapore? Our group is very multinational. Singapore is close to Japan. The tax haven aspect of it is very good.
Right.
And in the US is very, how should we say, unbusiness friendly.
Try California. No, the reason why I ask is I'm originally from Malaysia, and Singapore got its independence from Malaysia. So our families are split between the two countries.
Well, my wife is in KL and my daughter and son go to, what do you call it? You pay for the school, what's that called? I forgot what they call that. international
school.
international school. Yeah, okay, that's what you say. So yeah, so they go to international school in KL now. They were in Penang. School wasn't so good, so we moved them to KL.
Right.
So about 2 months ago, so they started in KL. So yeah, so
Yeah, why don't they study in
I
Malaysia?
like Malaysia, by the way. So except for the toilets. So
And the politics. The politics is horrible.
well, I never got involved in that. So that's
No, you
yeah,
don't have to get involved. The country is so corrupt, you don't have to get involved.
yeah.
So why don't your family study in Singapore, not instead of Malaysia?
Well, Singapore at the time, Singapore didn't the timing for the schools weren't good
Oh,
at the time. And also Singapore is pretty expensive to live in. We did look at it, but I gotta tell you, I think you look at a 1-bedroom apartment in Singapore is equal to a 5-bedroom apartment in the US. So, or what you would call a mansion, right? So,
but the city is clean and
oh yeah.
very well managed. You pay the same price in California and it's a dump.
Well, there you go.
Depends on where you live in California.
Yeah, actually, I grew up in Ycbo, Calamasa, where a little bit, and then we moved to Blythe, where my mom was born. Actually, both were very nice. Cool. That's decades ago, but yeah, I understand California's changed a lot since then. So you're
just jump in. I was in the Singapore airport back in the 80s. It's the cleanest airport. Remember, I can never forget it.
well. I was there 2 years ago, and I was surprised that when I went into the toilet at the Singapore airport,
Right.
that it was cleaner
Yeah.
than my table at home. The floor was cleaner than my table at home. So,
Well,
amazing.
they got special toilets there too. No, without getting into
Oh, you're talking about the European.
yeah.
Yeah, they are different, aren't they? Yes, we have those in Japan. Somehow the Europeans don't like toilet paper, so that's why those were actually created. So, so anyway, yeah.
So I'm curious to know if you've been able to fab devices using the yttrium, barium, copper oxide.
Yes, actually, we made now we're in the process of developing a YBCL device that's nano size that can detect X-rays, and we have another one for gamma radiation. So, and they're nano size.
And
They don't require energy input.
They're hard enough to withstand gamma and the
Yeah.
devices. So like I've done experiments with infrared sensors where you had to do radiation hardening by thinning it, making it really thin, for example. So the capture cross sections large enough that you're not likely to get it sustain any damage.
Our capture cross section is 11 angstroms.
In angstroms. Oh, okay. And then
the device itself is about 10 nanometer in diameter by 100 nanometer long.
by
But,
one,
but the cross section of the device is 11 angstrom. So
wow, that's pretty thin.
pretty thin. Yeah.
Yeah. Okay. Well, that sounds cool.
So,
I
well,
can't
it's
wait
the
till,
Pacific
I
Day is
can't wait till,
definitely
is it
cool.
all gonna, is it all like, unpublic stuff right now, but it's gonna come
Totally in
out?
public. So
Okay.
totally in public. So, and yeah, we have quite a few things that we're working on that in basically are pretty amazing things. So
Well, thanks for sharing.
yeah.
I appreciate it.
Hmm. So
How do you 3D print Ycbo? I mean, from my research, in order to create a crystalline structure out of it, you have to like maintain a very steady high temperature for quite a while in order to build up a crystal. How would
you have
you-
to sinter it, right? And then not only do you have to sinter it, but you get tons of breaks that come out of the mold. I'm not sure if he's here, but
yeah,
maybe he's left.
that's how everybody else does it. So our materials are unique in the sense that we have no recentering. So we can well, we have, actually I shouldn't say can, we have done it. We've taken cardboard and paper and spray painted with our YBCO and flow and basically demonstrate the Meissner effect. So stuff like that. So so we can spray paint our YBCO. We can mold it by 3D printing. We use resin-based 3D printing for that. Well, so we draw it into wire. There's lots of things that we're doing with it. So
Okay, that's pretty interesting. I didn't know you can make a wire out of a ceramic.
well, the way we do it, sure you can.
Mm-hmm.
So, but a lot of this stuff, you know, is not public. I have a paper that I published 2 years ago, and I've got 2 more papers coming out in the next few months, but none of it talks about anything that I've told you about. So,
Okay, so we definitely have to connect after the conference about those other things we talked about and see what we can do. Anyone else? Tim,
Yeah,
I think
I think we're all set.
we're all set.
Well, happy Easter to everyone. And if you celebrate another holiday, happy other holiday. So yeah, let's call it a night. Let's call it a night.
Happy Easter.
Happy Easter.
Happy Easter, guys.
Live long and prosper.
All right.
Have a good one, guys.
Okay.